Hello and welcome to another tutorial on dev.java, and in this tutorial we're going to look at the next item, which is compiling your first class. So we said that you download the JDK, unzip it, put it in some folder on your operating system, and then you want to tell operating system how to find the development tools which are inside the bin folder of the JDK. And we add the bin folder to the path environment variable so that the operating system knows where to find those applications. And then we also define Java home, which points to the home directory of the JDK. That's because first of all, it's easier if we want to get the absolute path of the development tools, we can use the Java home environment variable, because if I say echo Java _ home / bin, it automatically gives me the basically the home directory, and the bin obviously inside the home directory. And as I said before, some tools like Maven, for example, they prefer to rely on the Java home environment variable. So Java home is not necessary in order to compile your classes and run your application. You can only do the path, set up the path, but Java home is good if you're using a third-party build tool like Maven, right? All the commands you will be typing now should be typed in the same prompt as one you use to set up these app variables. And the reason was that, as I mentioned, it's defining these environment variables in this tutorial as a local environment variable, which means so whenever you open up a terminal, it keeps track of the local history, for example, the variables that you define. But these are not global environment variables. For global environment variables, you have to save those commands. For example, export path equals this in a file that whenever you run the terminal, loads all the lines of code into that file. As I mentioned, in Linux or macOS, it's bash rc or bash profile. And in Java, in Windows, there should be some way to do the same thing, right? So compiling and running your first Java program, whether you follow the Windows, the Linux, or the Mac OS path, the remaining is the same. And this is again about the platform independence of Java. So whenever you have Java C, Java compiler, you run it on any platform, it creates the same class files. So it's pretty the same, right? Change the directory where you save your first class. The example here is my first class.java. You can check that you're in the right directory by typing dir. On macOS and Linux, you can say ls, list directory. I'm right now here in this directory, text blocks. Or you can say pwd, print working directory, which tells you where you are, right? And whenever you open up a terminal, executing a command always happens with respect to some working directory, where you are in your file system, in your operating system, right? It will show you the files you have in this directory. You should see my first class.java. Check that your compiler is accessible from this directory by typing the following. This command is the same whether you are on Windows or Linux. Java -version, I tend to use the ---- version. I think both are supported, Java -version and ---- version. I believe ---- version is a more common thing for command line application. That's why I prefer to use ---- version. But version is also supported. And note that we are trying to access the application using its name, not a path, not a relative path or absolute path. Which means when I execute this command, operating system realizes Java is an application. It searches the path, all the folders in the path in order, from the first folder that is inside the path and then the second, to find an application that has this name. The first instance of the application that has this name, the operating system assumes that that's the application that you want to run, and then it runs it. It should tell you which version of the Java C you are currently using. Obviously, they're using Java here, which launches the JVM, but they're talking about Java C. So this is a typo. This should be Java C -version. So Java C -version tells me I'm using a 15, Java 15. So instead of Java, this should be Java C. If it gives you an error message, then you need to check your Java home. You don't need to check your Java home. You need your path environment variable. The reason it says that you need to Java home, because when it defined in this tutorial, when it defined the path, it appended the Java home environment variable / bean. So it used the Java home environment variable to set the path, right? Modify the path. But you don't need to do this. You can, instead of Java home, you can just write exactly this: users, whatever, contents, home, and then bean, right? So you don't need to use another environment variable to define this line of code which appends the JDK, the bean, directly to the path. But that's why it says also check Java home, because as I mentioned, if there's a space in the name of any folder in your environment variable, you have to escape it with a backslash or put everything in double quotes. So be careful about that. And okay, so let's assume that Java-C works fine. We can execute it. Now you're all set to compile your first Java code. So you give it Java-C and then the Java source file, and it creates a class file. And as I mentioned, it doesn't necessarily create only one. It might create more than one class file, because the idea of Java is that one class file, so one dot class per class definition. And we know that a source file, a Java file, can in fact have the definition of multiple classes, right? So when you compile a Java source file, you might end up with multiple class files. This happens if you have nested inner classes or just definition of multiple classes in a source file. As I mentioned, if you have multiple definitions and those are not inner classes, you just have flat 3-4 definition of class, only one definition of the class can be public, and the name of that class must match the name of your source file, right? Two things may happen at this point. You may have error message telling you that the compiler cannot compile your code because of errors in your Java code. You might throw exceptions or compilation error. You will need to fix them before being able to move on. So if you have compile check exceptions or checked exception, like file not found exception, IO exception, you have to handle these at compile time, right? You have to tell the compiler, hey, I have implemented some thing to be able to handle it, right? So for example, if I let's create a new class here. Let's call this test2. And if I just create a main method and say basically file f1 is new file, and let's say here test.txt. Now at the moment, obviously the first compilation error here is that it says that you have to import it, right? So you might get compilation error if you haven't import something, right? And we know that in the JDK, basically the idea is that java.lang imported automatically, right? Imported automatically. So you don't need to have explicit import for any class that is inside Java lang, right? Lang is a package, right? All these classes from here to here, you don't need to explicitly import them. But for example, annotation, constants, invoke, ref, module, reflect, runtime, right? You have to basically import this. Only Java lang package, but it doesn't mean classes that are inside packages inside Java lang. You have to also explicitly import them. Only classes that are flat inside the Java lang. For example, if you look at the reflect, we have, for example, this method class, right? If I said method m1, it gives me a compilation error because it says that cannot be resolved to a type. So you have to import it. And it says that Java lang reflect. That's the one that Eclipse could find. And you see, I had to explicitly import this, even though this reflect package is inside Java lang, because only the classes that are flat in the hierarchy inside the Java lang, you don't need to import them. And these are the most classes, for example, byte or boolean, for example, boolean, right? So I don't need to import it. It doesn't give me a compilation error because it's explicitly imported when the JVM is run, right? And the Java compiler knows that. And obviously this only applies to Java lang. Any other thing, for example, Java desktop, all these packages, Java, JavaX, Swing, for example, you have to explicitly import everything, right? And that's another reason that you pretty much end up using an IDE to automate this process. You don't want to worry about how to import the stuff, because you have to give them this import is the class path of the file of the class that you're importing, right? So you have to know the fully qualified name and that's difficult. You cannot really track them because JDK is very large. So you want to use an IDE to make sure you don't make a mistake. Now this is one. So the first compilation error you might get is about imports. The other one is checked exceptions or compile time exceptions. These are the exceptions that you definitely want to handle them at compile time. Otherwise, the compiler refuses to compile your Java source code, right? It refuses because it says that you have to handle the exceptions. And again, this kind of exception handling, obviously other programming languages like C++, they don't provide this kind of a strong emphasis on exception handling, but Java from the first day they decided to make sure that maybe it makes the code more verbose, but then I think it's a very good idea to always be able to handle it. And again, the fact that IDs are very small and intelligent, IDs are very smart and intelligent at this point, and they can automate a lot of this stuff. So for example, let's say you want to say something that throws an exception. Let's say you want to write to a text file. Txt file is new file writer, right? And file, let's see, with F1, right? Now this this file writer is inside Java IO, right? And note that as soon as I typed it, Eclipse automatically imported this. So again, this is one way to really not worry about imports. So the first thing is you have to make sure you import it. File writer class is inside the java.io package. But there is another compilation error. It says unhandled exception type IO exceptions, which means there is an exception that the compiler forces you to handle it. So in Eclipse, you say either throw it out of the main method. So if an exception occurs, I just tell the compiler, hey, I don't want to handle it. I let the caller handle it. In this case, the caller is the JVM, and JVM doesn't know how to handle it. So it just terminates your application, right? So this is one thing. The other thing is, or you can tell it, okay, I am going to handle it using try catch, right? So we have this, and then txt file dot write, for example, we're going to write write a text, a string, hello world, right? And then note that the file writer is dealing with the files, so we have to also close the file, underlying file, right? So whenever you use a native resource like a file or something else, you kind of need to always close it so that you tell the operating system to release the or JVM releases the whatever resource it's holding on. Usually it's just a file pointer if you're familiar with C or C++, etc. So we created this class that handles the writing to files, and then we have to close it. But then if it cannot find the file, so when create the file class doesn't check if this is a actually valid file, right? But the file writer also it says that if an exception occurs, but the type of exception is not related directly to file. It's IO exception. Maybe the file writer says, maybe I won't be able to open this file. Even if this is a valid file, I might not be able to open. So this is some sort of IO error or exceptions, right? Somehow maybe the file is corrupted. It happens. It's not common, but it's definitely a possibility that the file is corrupted. Something happened. It's not a valid text file. The encoding is wrong, etc. Right? So let's see what happens if we run this. So in the console, we get this test.txt, the program ends, and then everything looks okay, and we have this hello world. So as you can see, this is how you can handle all these compile time exceptions or errors that the compiler might throw at you. There are some basic ones. For example, if the naming is not correct, if a name of the variable cannot start with a letter, for example, syntax error. But so the job of the compiler, Java C, is more than just telling you syntax errors. It also checks for imports. You want to make sure that everything at compile time is available on class path. And the only exception to this is when you dynamically load classes at runtime. And that's when you use a class for name. So you try to you try to look for a class on the class path dynamically at runtime, right? So this is the only case that you don't worry about the basically the import, and the Java compiler gives you a pass on that. It doesn't like bother you with that. The other cases is when there is a checked exception that you need to handle. All right. If the compiler remains silent, I mean, it can give you warnings. Warnings are okay. The best practice to always handle the warnings. For example, here I have a warning, right? What is the warning? The value of the local variable m1 is not used. It says that, hey, you have this variable, you're never using it. Just maybe it's best to just get rid of it, right? You want to make sure that your compiler doesn't give you any warnings as well. So warnings are fine, but it's always best practice to also get rid of all the warnings, right? And Eclipse has a lot of things. For example, if you say import, if you have unnecessary imports, Java, lang, I don't know, reflect, for example, method. We have this import, we're not using it. So this is a compilation warning saying that, hey, you're not using this import. Note that having many imports, it doesn't change the size of your class file, right? So imports are nothing like, so if you're familiar with C or C++, we have include statements, right? Hashtag include and some header file. But in that case, the more you include this, the more the C or C++ compiler actually copies contents from those files into your source file. And at compile time, it just makes your file bigger and bigger, right? That's the meaning of a static compilation. You bring the entire world that you need to compile your application. But in Java, it's not like that. In Java, you can have many imports and it doesn't change the size of your class file after compilation. Even 1 bit, right? It doesn't change. These are all directives that's saying that these classes, this type, you have to tell the JVM at runtime, what is this type? This type corresponds to this type. This is an import directive that, hey, at runtime, when you want to create F1, which is of type file, this file is actually, you can find it here. This is the class path, Java IO file. So go to the Java package, go inside the IO and find this class, file.class, and that's the type that you need to instantiate from. So imports have nothing to do with the size of your class file when you compile your source file. So you can have many imports, unused imports, doesn't matter. It really doesn't matter, but it's always best practice to get rid of them. In Eclipse, Command-Shift-O organizes the imports, or you can just right-click, source, organize imports, and it gets rid of all the warnings, makes a lot of the imports explicit. All right, so if the compiler remains silent and does not complain about anything, congratulations, it means that your Java code has been properly compiled. Checking the content of the directory again should show a new file in it, my first class.class. And we can also go and quickly look at the class file. So as I mentioned, as in Eclipse or any IDE, as soon as you save your source file, it also compiles them and puts them in the bin directory. In Eclipse, it's a bin directory, which is a direct match in folder hierarchy with your SRC. And then we have test2. So if I open it in the basically editor, we have our class file. So it has the fully qualified name of the class. It's in this side, inside this package, another package, and the class file. And then it says which version of the Java compiler was used to compile this, version 15, and it's the magic number 59 and 0, right? This corresponds to JDK 15. And then it has the descriptor of the methods, right? Method descriptor. Hashtag 6 means this is the 6 string in the constant pool of the class, right? So each class has a constant pool that has all the descriptors. It says that go to the sixth entry of the constant pool of the class and look up what the description is. So it takes no parameter and returns void. That's the constructor. And the name of the constructor is init. The first is always loading the this reference to the object, and then we're invoking the constructor of the superclass and we're returning. So 3 lines of code to run the constructor of this class, right? There is nothing here. So I hope you enjoyed this lecture, and please stay tuned, and I'll see you in the next one.